when 10 identical cells, 10 identical cell means number of cell is equal to 10 all identical cells. Identical cells. It means EMF of each cell is equal to epsilon and the internal resistance is R. Or in series. 10, it means 10 identical cells are connected in series. Third cell and nth cell connected in series through some external resistance. Through some external resistance. So that is E and each cell connected to an innate resistor 59. R is equal to 59 ohm. R is 59 ohm. Current is found to be 0.25. 0.25 ampere. So it means we can say current is given. So since I is equal to 0.25 ampere, we can write what is the expression of current. Current is equal to EMF total, or we can say net divided by R total, resistance total, which is equal to what is EMF, net EMF 1, 2, 3, 10th one. So net EMF is equal to 1, 2, 3 up to 10 times is equal to EMF net is equal to 10 times of this one, and R equivalent means net 1, 2, 3, 4, that is 10 times of R, because all are in series. This is, we are talking about the series. So EMF is equal to R series. So I can be given EMF net is equal to 10 times of V divided by R total is equal to, so R total is equal to, because this is internal resistance plus external resistance. Internal resistance plus R equivalent of internal resistance plus external resistance is equal to 59 plus 10 R. R we can write 10E plus 59 plus 10 times of R, where I is, what is the value of I? I is equal to 0.25. 0.25 can be written as 25 by 100. That is 0.25 is equal to 10 times divided by 59 plus 10 R. This we can write it here for n identical cell, that is when it is in series 10 times divided 59 plus 10 R is equal to 0.25. This is for the series combination for the given cell. This we have written for the series combination. Now let's write for the parallel combination. For the parallel combination, same cell is connected in parallel. So let's write for parallel, first cell with internal resistance, and all are, of course, all will have same and connected in parallel. And we can go up to this one. 10 cells are connected in parallel with the internal resistance. All will have this one, all will have this one. So when 10 cells are connected, of course, with an external resistance R. Here R. See, they are connected in parallel with the external resistance of 0.05 ohm. The external resistance is equal to 0.5 ohm. The current is found to be, so current will flow like this. At this junction, it will flow like that. So the current is equal to 25 ampere. The current is 25 ampere. In the sense, we can write it as, so what is the net EMF? Net EMF of the parallel combination. Parallel combination, this divided by this, it will have a denominator part, this divided by this divided by this divided by this divided by this, that is E by R 10 times, E by R into 10 times, because we will be adding all, E by R plus E by R, that is 10 times, and divided by 1 by R, all 1 by R, 1 by R, 1 by R, this already we have seen it, plus 1 by R. Therefore, net EMF is equal to 10 into EMF one cell divided by 10 by R. This cancels, is equal to EMF. EMF net for parallel. We are talking about parallel. Already we have repeated several times. When identical cells are connected in parallel, the net EMF is equal to EMF of a single cell. EMF of the single cell. So EMF net. And what about the resistance R equivalent? We can do it anyway. This is equal to 1 by R equivalent, which is equal to 10 by R, and reverse it, R equivalent is equal to R by 10. R by 10, this also we can calculate very easily. All are identical resistance in parallel. So in parallel, all are identical resistance means take any one resistor divided by number of resistors, that is one resistor divided by number of the resistors, R equivalent. So what is the I? I is equal to EMF net. EMF net is this much divided by R. What is the R? R is equal to 0.05 plus, that is capital R plus this EMF, equivalent EMF, that is R is equal to R plus R equivalent. So R is equal to 0.05, R equivalent is equal to, what is the value of R equivalent? R by 10. R by 10, this is the equivalent. Okay. Now, which is equal to, what is the current is given? 25 ampere. In parallel condition, this current is given as 25 ampere. That means we can write it as a 25. 25, then if it is 25, then we can modify this equation also. We can modify the equation, cross multiply, this will become 10, and cross multiplying this will become 0.5 plus R, the 10 will go on the top this much. So it means this we can take this portion, that means we can come to the conclusion, that is 10 times of epsilon naught, 10 times of epsilon naught divided by 0.5 plus R, 0.5 plus R is equal to 25. This is the two equations we got. This we can call it a first equation, this we call it as a second equation. After this is for series and this is for parallel. So with the given condition, we have driven two equations, first equation and second equation. So now we have to calculate the internal resistance with the help of the derived equations. What is the derived? Because there are two unknowns. Two unknowns meet what? One unknown is internal resistance, next is EMF. So we got two equations. So two equations we got means this equation we can write it as 10 times of epsilon naught is equal to 0.25 into 59 plus 10 times of R. This equation, if you written it here, cross multiply here, and this equation you can write 10 times of epsilon naught is equal to 25 into 0.5 plus R. This is another two equation. So comparing these two, we can compare these both two, because this equal to this. It means we can say 0.25 into 59 plus 0.25 plus 59 plus 10R is equal to 25 into 0.5 plus R. 25 plus R. So this equation we can write 25 by 100 into 59 plus 10R is equal to 25 into 0.5 plus R. And this can be written. So this and this we can cancel it out. So this will become, multiplying, taking this 100 that side, this is 59 plus 10 R is equal to 100 into 0.5 plus R. 0.5 plus R, that it means, that is, this became 59 plus 10 R is equal to 0.5 into that is equal to 0.59 is equal to 50. 50 plus 100 R. R and calculation, this is 59. We take this 50 this side, that is 59 minus 50 is equal to, take this side and take that one this side, that is 100 R minus 10 R, that is 90 R is equal to 9. R is equal to 9 by 90 is equal to 1 by 10 is equal to 0.11. So we calculated the internal resistance of the cell is equal to R is equal to 1 by 10 ohm, R 0.1 ohm. This we have calculated value. Now we have to calculate the EMF of the cell. What is the EMF of the cell? To find out the EMF of the cell, we can use any of these two equations, because EMF is involved here also. So we can, let us use, this is comes in fraction, let us use this equation. This also, let us take any one of the equation. 10 times of epsilon naught is equal to 25 into 0.5 plus R. Say this is for the parallel circuit, we have taken, that is 25 into 10 epsilon R plus 0.5. We have taken this equation. In this equation, we will substitute the value of R. R 10 times of epsilon naught is equal to 25. 0.5 for easy purpose, 5 by 10 plus R is equal to, of course we have find out 1 by 10, R is equal to 1 by 10 ohm. So 10 times of epsilon naught is equal to 25 into 6 by 10. 5 plus 1, 6 by 10. R epsilon naught is equal to 25 into 6 divided by 100 volt. Or epsilon naught is 25 is equal to 150 divided by 100, so is equal to 1.5 volt. So we can write internal EMF of each cell, identical cell, is equal to 1.5 volt with internal resistance of each cell is equal to, internal resistance is equal to 0.1 ohm.